Hi, this is going to be one part of completing the square set of videos. This one's going to focus on some introductory material that's going to explain how the name fits the concept. So, when we hear the words completing the square, what does it actually mean? Here I have a diagram listed here that has x squared, a rectangle that is x, which would be a 1 by x, another one that's horizontal that is also x, and then a 1. We can see in that picture that the sides are both x plus 1 units, so the whole area is x plus 1 squared. Usually when we're going with completing the square problems, we have an example such as x squared plus 4x, and it says complete the square. Okay, so here's how we're going to do that. We're going to start with an x squared, and then also 4 x's. Well, I'm going to take 2 of them and put them over here. And remember, I'm going to be trying to make a square, so I need to make sure the width and the heights are equal to make the square. So I'm going to take the other 2 that are horizontal. Now we can see we do have the outline of a square shape. It would be x plus 2 wide across the top and x plus 2 wide along the side, but we're missing something. And it's the part that's missing that is key to completing the square. What is it that we actually need to add to complete this square? Okay, so if we're given x squared plus 4x, we need still 1, 2, 3, and 4 unit squares. Okay, so to complete the square for x squared plus 4x, we need to add on another 4 units. And there we go. What happens if that middle term has an odd coefficient? So x squared plus 3x. Well, as you might imagine, since we need to keep things even across the top and along the side, we need to split some of these items in halves. So what I did on the first one on the left-hand side was I cut one of the x's in half, so we have a half of an x. And I also cut one of the ones in half, so we have a half. And then in the very bottom right corner, we have a quarter, half of a half. So for the one on the left, we do end up with each side being x plus 1.5 units wide with an area that is x plus 1.5 squared. So it does indeed make a perfect square in this case. Perfect square trinomial would be x squared plus 3x plus 2.25. It's the 2.25 that we added on, and you can see that by adding the 1 unit, the half of a unit, the other half of a unit, and then a quarter. Looking at our extra example then, what would we need for an x squared plus 5x? Well, let's start with an x squared. To get 5 x's, we can use 1, 2, 3, 4, and now we're going to need some halves. So there's 4.5. I'm going to slide this down here. And that would make 5. Okay, so what extra pieces are we going to need to complete this square? Well, we need 1, 2, 3, 4, 4.5, 5, 5.5, 6, and this piece is a quarter. So we indeed need to add on 6.25. So the perfect square trinomial for x squared plus 5x, if we complete the square, would be x squared plus 5x plus 6.25. Please pause the video right now, and I want you to try to draw a diagram for the problem below for x squared plus 8x. So go ahead and pause the video, and we'll resume in a few seconds. Okay, now that you're back, hopefully you attempted this problem. The diagram for this problem would look like this. We would put 4x's across the top, 4x's going down, and we would need an extra 16 units. So the perfect square trinomial would become x squared plus 8x plus 16. The reason for this video is to help give the picture of what it means to complete the square. Recognize that we could put a negative sign in front of the x term, so we could have an x squared minus 8x. It would work the same way, except instead of using x pieces, we would have negative x pieces. The part that we would add on would still be positive 16, but that is kind of the history behind where this idea of completing the square comes from.